Okay, we've worked with slope-intercept form up to this point, but we've never actually graphed from a slope-intercept or put an equation in slope-intercept and then found out where it was at. Every time we've graphed up to this point, we've graphed by finding out x values and then plugging them in and finding it, making a chart, and then plotting that chart onto the plane, and then finding out exactly where that lands, and then connecting the dots. We're going to be moving a little bit further in this lesson, and we're going to be talking about how you can graph directly from the slope-intercept form, and also how you can take an equation or a graph that's already existed and come up with the equation from that using the slope-intercept form. So a couple of things we have to define first of all. This is my equation of a line in slope-intercept form, y equals mx plus b. In this case, slope is m. M is how much my rise over my run. That's my slope, which we've covered before. And then I remember that my rise is my change in y, and my run is my change in x. And I have another term here. This is new, and this is my b. For this formula, b is my y-intercept. It's where it crosses the y line itself. So in order to do this, if they asked me to take this equation and said, graph the equation of the line that looks like this, 2x plus y plus 5 equals 0. They've given it to me in standard form, not y-intercept. So in order to get it in y-intercept form, I need this to look like this here. I need y all by itself. So I subtract 5 from both sides to begin with, and that gives me 2x plus y equals negative 5. We're off to a good start here, except I still have a 2x on the wrong side. Now the tendency would be to put the 2x back here, but remember my format is a mx plus b, not a b plus mx. So I end up putting the negative 2x in front of the negative 5. So y equals negative 2x minus 5. This specific problem doesn't have a fractional slope, but I need it to be fractional to be able to tell what this is. So in order to do so, in order for it to be fractional, I need to go ahead and put it in fractional form. Well, the good thing is that every whole number exists as a fractional form as well by putting it over 1. So now I have negative 2 over 1 x minus 5. We're going to identify the slope from this and say the slope is negative 2 over 1. That's my m, my slope, my rise over run. My y-intercept is negative 5. Now if that was a positive out there, it would be a positive 5. But the problem that we came up with is not. It's a negative 5. From this point, normally at this point, we would start plugging in values for x and finding values for y and making our chart. But this is where it's new. This is what we're going to do. We're going to start with our y-intercept. So where is that? Well, that happens to be at 1, 2, 3, 4, 5. Negative 5 is my y-intercept. I'm going to put a dot there. That's just a placeholder to keep that in my mind where that is. From there, I look at my slope. My slope is going to be rise over run. It's rising negative 2. Well, how do I rise negative 2? I go down 2. The next thing it does is it says it runs or goes left and right 1. So I jump over 1 and I put another dot. Both these dots exist on my line. Because of that, I can take them and go ahead and draw my line from my dots. And there I have how I graphed it from the equation of a line. But what if they gave me a line and it looked something like this and it crossed through here? We're going to pretend that crosses nicely there and there. And I look at that and I say, well, what's the equation of this line? Well, from this, we would start out with my y-intercept. Well, where's my y-intercept? 1, 2, 3, 4. So I know my b equals positive 4 on this one. Where is my a point? Well, it's crossing here. And if I looked at it and said, from here, if I went rows down, rise over run, 1, 2, 3, 4. There's my rise. From there, 1, 2, 3. There's my run. So this is my change in y over my change in x. But a negative divided by a negative is going to leave me with a positive 4/3 for my slope. Really close here. I remember my equation of my line is y equals mx plus b. So I go ahead and start plugging in. I know m and I know b. So it's y equals m, which is 4 over 3x plus my b, which is 4. And this allows me to take, for the very first time, take the graph that I was already given and come up with an equation that describes that graph. Now, keep in mind, I have two variables. Why? Because they are changing as it goes. As x changes, y changes. As x goes up, y goes up. As x goes down, y goes down. And that's telling me this equation right here. How fast is it going up? Well, it's going up at a rise of 4 for every 3 it runs. And this is where it crosses the y-intercept. So I can go either direction using my slope-intercept form, as whether they're giving me an equation and I'm graphing it, or I'm looking at a graph and I'm coming up with an equation.